Hello there, and welcome to everyone joining us for this latest IoT Central Webinar. I'm Clive Maxfield, everyone calls me Max, and I'll be your host. In addition to being a practicing engineer, I also act as a technology consultant, author, speaker, and educator. I'd like to start our webinar by thanking SECO for sponsoring today's event. SECO is a leading supporter of the IoT Central community, and we're very grateful to have them as sponsors. Today's webinar is entitled Edge and Cloud Computing, How to Maximize Value from Data in the IoT. Before we begin, I'd like to briefly review the format of today's proceedings. This event will be 1 hour long. We will have one presenter who I'll introduce in just a moment, and there'll be a Q&A session after the presentation. If we run out of time, any unanswered questions will be answered via the email address you provided when registering. Now, I'm very pleased to introduce today's speaker, Dario Freddi, who is the CEO of SECO Mind. Whenever you're ready, Dario, take it away.
Thank you very much, Max, and thank you for all the viewers for coming up today and seeing what I have to share with you. So today, as Max has said, we will walk through, let's say, what is the interesting bit of the IoT when it comes to edge and cloud. Now, you might be used to hear about IoT when it comes to connecting your own device rather than looking at IoT platforms. What we do at SECO is to try to join this gap together and make it so that developers, most of all, because we are a company that targets developers when it comes to the solutions we provide. And you will have a very clear demonstration later on. And users and customers to make it so that they can tackle the full chain that the data has to go through from the sensor to the cloud and provide coherent and consistent solutions from all the value chain. And nowadays, I do believe that it's more important than ever to consider both ends of the spectrum because they are equally important. And most of all, you cannot really think about a system which isn't convergent in the technological era we're living in, where the field has become more and more important, and the field has much more possibilities than it used to have before. And when we talk about the edge, there is a lot of fuzz when you think about what can be done today. And artificial intelligence is definitely, on one hand, the newest kid on the block. On the other hand, one of the most attractive kids on the block for sure. And it's very easy to see why. I mean, we've been spending a lot of years in trying to figure out how to collect data in the most efficient way. And I think that ultimately we got to the point where technology makes it pretty easy to do so. But what came afterwards was that these data were just something that we had, and nothing of value was coming out of it except some very, let's say, small and small use cases in which the value was not that much anyway. And then when AI came to the block and the buzzword came in, because at the end of the day, every cycle starts with a buzzword. Somebody thought that the AI could have been the key to make it so that the IoT game will have been more interesting once again. And I think that this is actually the right way to approach that. When we talk about AI, we are talking about the capability of making decisions out of existing data. AI, to me, can be explained by saying it's decision support. I don't like the usual definition of AI as the magic stick by which you solve random problems. AI is applied mathematics, and some pretty advanced one, by the way, and it's something that has ever existed. But nowadays, the technology, the use cases, and the popularity that plays a big role enables us to talk about this at a different level. And of course, that is the way, that's the key to unlock the potential of data. That's why it's becoming so attractive, not only just in the communities and in the developer communities, but also among customers who finally see ways, real ways, concrete ways, actionable ways by which data can be converted in something that is valuable. And of course, keep in mind that the average user will have a very hard time in understanding what data is meant for and doing something with data. As developers, as companies that provide technology, as technological people, we need to provide the right tools to the end users to harness everything that data can provide in the easiest and fastest way. Now, why is the edge important in such a scenario? Because AI can be very expensive. And now, if you think about the IoT and the state of things in the IoT, we've been flooded by a handful of great cloud technology over the last 10 years or so. But this cloud technology comes at a price of two different kinds of prices. The first one is transferring data, because transferring data has a cost and sometimes poses very big challenges which go beyond the cost itself. If you think about computer vision, no one in his right mind will think about getting some video streams at the edge and throwing them into the cloud for doing some image recognition, unless you have some very, very specific use cases which exist, but are definitely not the majority of them. And on the other hand, of course, processing a large amount of data has its own costs. If you have a fleet with thousands or dozens of thousands of devices, all of this can become very, very expensive. But over the last years, the edge has evolved significantly to provide a great environment for deploying and running these algorithms and this model right at the field. And of course, this does not only distribute the infrastructure, this distributes how the cost is laid by. And most of all, it also enables new use cases that we couldn't basically do before. Now, think about, if you have a camera onto a device, you can do recognition of images and just send metadata over the cloud to make some sense out of that. But the biggest processing part, the most expensive part when it comes to data itself, and the processing power that is required to make sense of this data stays down at the edge. Scale this up to a significant amount of devices, and you will see that the use case is making some sense at this stage and could not have made sense if you didn't have this kind of access to technology. And of course, last but not least, we are seeing more and more attractive SoCs and dedicated CPUs or FPUs or anything else in the field that are making life a lot easier to developers by providing them dedicated frameworks to run AI or ML at the edge. And this is something you cannot really do anywhere else. Sometimes these processors not only give you horsepower, they also give you some development frameworks, which are pretty handy. And so, I think it's a very good time to be a developer in the edge space, and the possibilities that are opening up today are absolutely enormous, and they are ready to be harnessed. And today, I see a growing interest in the market when we go out to customers and talk about edge AI. I mean, everybody is ready to listen. Everybody knows that this is something that is making a cut. And of course, this is really how the IoT, I believe, can make a further step forward when it comes to its use cases. But then, of course, when we talk about the IoT, we are not talking about small islands that have to talk to themselves, right? To me, the meaning of IoT is having a lot of different devices in a lot of different environments, potentially doing very different things amongst them. And most of all, to have a distributed and fragmented fleet from any standpoint, including what the fleet is doing and how the fleet is even made of. I mean, you could have different devices doing the same thing and the same device doing different things in the very same fleet. The cloud is relevant because at the end of the day, you need to make some sense out of all this fragmentation. And this not only concerns device management and fleet management that, of course, have been a prominent topic over the years, and of course they are still relevant, although somebody could argue they come as a commodity right now when you talk about putting some devices out on the field. But when you talk about data and you talk about making sense of fragmentation and the mess that you have on the floor, because that's what happens, the cloud is there to make some sense. And I do think that even before we talk about AI, we need to talk about how this data is looking like. Most of the times, you end up with a scattered data scenario in which you have data which is unstructured, rarely pre-processed. When it is pre-processed at the edge, as we've seen before, it still needs aggregation and it still needs to get some sense in the bigger scheme of things. And of course, it requires order, because at the end of the day, if you're managing thousands of devices or maybe even more, you need to make some sense and further reduce what you're seeing. So the cloud is just the tool that allows you to make sense out of this complexity and use everything that you have on the field to make some sense out of the bigger picture. And I do believe that when you look at the situation that way, you really see that there's a different building brick when it comes to the bigger picture of my field has to generate value, or I need to get something out of the field, because you need to get something out of the single device or out of the single situation you're monitoring and you're looking at, and you need some sense to make some sense out of the bigger picture, or a bigger picture, which could be maybe a specific country, a specific continent, a specific something, or a specific group of devices that is grouped by a different logic. But ultimately, you still need aggregation, you still need something that stays on top of the single device and the single use case. And of course, as much as what I've said before on the, let's say, newborn processors that are looking at AI and making it easier for people to deploy and develop on the edge for AI, the cloud still provides you an unmatched ease of development that makes everything faster and more flexible, of course, when it comes to deployment and pulling together all the threads and making it so that your application can go into production. So I really think that when we look at what is a modern solution for the IoT, it is not really a choice between should I use the edge, should I use the cloud, or should I leverage the edge more than the cloud, or the other way around. It's how do I leverage both of the ends to make it so that my pipeline, my data journey, my IoT fleet is as efficient as it could possibly be. But I think that the answer lies nowhere, because when you look at the average product that you put in the field, this answer changes over time. Just as your product requirements change over time, just as your code base changes over time, just as your company or your project, depending on what kind of stakeholder you are, changes over time. And so it is fundamental to keep an open-minded approach. It is fundamental to realize that software is ever evolving, and it's probably more evolving than ever today and these days. And a valid product is a product that can evolve and can evolve fast and keep up with what's next for keeping it relevant. And so, when you put everything together and you mix the two things, you have really an unmatched flexibility. Just think about, the kind of workload you're running. You may be running a specific model, on TensorFlow for some reason. You might be running some Python code. You might be running some APIs, which are backend in Go or Java or whatever it is. And all of this can probably run on one end of the stack or both ends of the stack. But your infrastructure on the cloud evolves, because that's what the cloud is meant to do. But the infrastructure on the field evolves just as fast these days, because you deploy more devices, or devices you deploy change over time. So the potential of moving together workloads from up above to down below becomes instrumental to making a product that resists to the sands of time, and most of all still makes sense after a while, and after you're at it, since you went to production first, and maybe now your fleet has scaled to 10 or 100 times than what it used to be, because your product has been very successful. Now, the solution that we put together at SECO, and again, when you look at SECO, you really are looking at a company that builds technology, and we have technology in our DNA, and our purpose is to make your products as simple as possible by providing you all the technology bits that you are required to use for making them happen, from the hardware to the software. And even though today we are just focusing on the software and the IoT, SECO has a very extensive product line of gateways, SBCs, and modules, and even open source hardware that can be used for building pretty much any embedded device you can think of. But when it comes to our own software offering, we have a technology stack that we call Clea. Now, Clea is a project that was born from pulling together different components and trying to make sense of the complex technology situation that I just mentioned. So we try to give you all the frameworks and all the tools to make it so that you can deploy a full and complete data journey while managing your devices from the sensors to the cloud, and to, let's say, balance your workloads and balance your algorithms, balance your intelligence, or whatever it is, all across the chain with the most possible, let's say, simplest possible user and developer experience. And we are so committed to developers and to the developer experience itself that most of what we build and most of what we develop is released as open source. So our foundational frameworks, which are Astarte and Agile, are released under AppH 3.0 license and are completely open on GitHub, and you can go on github.com and look for them. They are completely open, and everything we do is completely given back to the community. So we don't just serve customers. We like to serve developers. We like our customers to become developers on our platforms. And most of all, we love to give back to the community because we are a part of it. We are avid open source users. Me, myself, I come from open source. And we believe strongly that as we look forward to the future and we look to what is going to be the foundation of future infrastructures in software, not just in IoT, for what it's worth, open source is just the way to go, and there's no turning back. On top of this, we also have a portal that is called Clea portal that is meant for creating apps. So the same experience that we give to framework developers and dashboard developers and IoT developers, we want to give to end user developers. So Clea is an application framework in which you can develop and deploy your own front-end dynamically to make it so that your end users can leverage your own small applications within a wider system that makes it possible for you to build services in a matter of a few days. Ultimately, we provide you with all the APIs, all the deployment structure, and everything you need to build your own services, evolve them over time in the easiest and most user and developer friendly way. That is our mission over every single end of the stack. We try to give you the very same ease of development and the same user friendliness when you're on a microcontroller and when you're just in the cloud. That is our mission. That is what Clea does, and that's why Clea is being successful these days. And just to tell you something about how we built it and what we are using, Clea is using a lot of open source software, and that's also why our base frameworks are released as open source, because again, we like staying true to our values, and most of all, we like to stay true to what we believe and what we use. So these that you see here are just some of the foundational technologies that Clea is built upon. I would just like to spend a couple words on Kubernetes itself, which is really the the cornerstone, which makes everything work. We build on top of Kubernetes to make it possible to orchestrate your own application and your own services, as I mentioned before, in the most user-friendly way. We like to say that if you're running Clea, you're using Kubernetes, but you don't need to be a Kubernetes expert to orchestrate your own applications. Again, our target is not necessarily the framework developer or the middleware developer. We like to target front-end developers, application developers, and everyone who needs to get a service out in the market fast. And I think this has really been one of the reasons why we are seeing a lot of deployments these days, and we see a lot of installations happening over all of the value chains of our frameworks. And as a testament to what we like to offer to our developers, we also have a lot of SDKs that are available for devices. So one of the usual pain points when you develop an IoT device is how do I put all the pieces together? Now, we try to make it as easy as possible for developers, and we know that developers have very different needs and use very different tools. This is why we are committed to providing the most extensive possible SDK range, and here you see our most popular SDKs today, out of which I would like to stress the ESP32 SDK. As many of you will know, ESP32 is a very, very popular microcontroller unit that is probably the most popular, I will argue, on the market today when you're targeting a specific IoT use case. Well, we provide a full-fledged framework that leverages all of the hardware capabilities of this microcontroller unit and gives you a ready-made solution that you can just use for capturing your data and sending your data upwards in the platform. Whereas when you are on Linux and you need to distribute your workloads with Agile, we give you a Rust agent that is currently not open source yet, but we plan on open sourcing it over the next few months, that is enabling all the orchestration of the pipelines I've mentioned directly on your own hardware without a strict requirement for a specific flavor of Linux, as long as you have a container runtime available on the device. And this really gives you all the tools to build your own applications and to give you all the, let's say, domain knowledge and the domain technology for orchestrating your workloads, not only on board of your device or in your cloud, but across your fleet. So I think that today we have a very extensive offering, and I would like to remark that everything that you see here can be found on GitHub. And of course, we also have extensive developer documentation, and we are very receptive to community comments. So if you find anything you don't like, or if you want to contribute, our doors are always open. And all that you have seen before are very open projects, and we treat them as such. So we like to call ourselves an open source company for what it's worth, for the way we manage software and the way we manage our deliveries and our product. But looking at what is happening right now in what we're doing, I put together some very small examples of two of them, which I believe are extremely significant when it comes to what I've mentioned up until now. And I think they are also a very good, let's say, way of showing you how important it is to balance and distribute your workloads when you start looking at more complex environments. And I believe that probably the most significant one is indeed the smart industry vertical. Now, we hear a lot about smart factories, smart plants, smart everything when it's in a manufacturing plant, but this really hides a whole degree of complexity that is unique to every single manufacturing plant. That is why most of these projects usually start with the best of intentions, but end up in a nightmare of complexity and integrations, retrofitting, and everything else. And actually, as SECO, we've just done a very important partnership with a key industrial player in Europe that has given us way more assets and skills when it comes both to the software itself and how we develop it, exactly for tackling the industry and the manufacturing plants. That's why we are being affected. But there is a lot of complexity and a lot of know-how involved. But when you go beyond that threshold, so when you acquire the means to understand what's happening in the manufacturing plant, and when you acquire the know-how and all the tools and the assets to connect these machines, there comes all the rest. Because factories and plants are the kind of environment where you have all sorts of constraints. This means that sometimes you cannot even rely on a cloud. Sometimes you need to deploy your platforms and your use cases internally and within the plant. That's also one of the reasons why we are basing our platform on Kubernetes, because Kubernetes allows us also to deploy all of the platform locally on premises. And this is definitely a key, let's say, a key decision point for whoever is making decisions in an environment where privacy or where the connectivity towards the outside world is limited for the most diverse reasons. But the surprising part is that when you manage to get over this very complex scenario, you really are looking at a lot of use cases where IoT and intelligence on top really are making a cut. We put together a couple bullet points here, but just think about this. In a manufacturing plant, sometimes you can find up to 100, 200 machines that are operating separately and sometimes are connected by some kind of internal monitoring, internal control, but most of the times are not, let's say, aggregated and are not monitored as a whole. Because we have a lot of KPIs, we have lean manufacturing, but when it comes to how the machines are performing and another set of KPIs, sometimes most of the factories are just still not there. So when you add the intelligence on top, you can really have an orchestrated way to collect all of this data, process it in real time or almost real time when needed, and make some sense out of it and give specific KPIs and results to whoever is operating these machines or even operating the whole plant and the whole factory. Quality control, I think, is one of the things that are the most interesting, because quality control sometimes involves cameras. Sometimes it might involve microphones. We've seen a lot of use cases in which listening to what was happening in a machine could tell us a lot of things about it. And that is the typical use case where you want to have a set of edge gateways which are capable of doing some processing on board. And that is also the typical use case in which you have maybe the same hardware that does a lot of different things, because you might be looking at a machine that requires a camera, one that requires a microphone, one that requires connectivity to some industrial bus, to monitoring some sensor. And so the the field is as fragmented as ever. And as such, the field is evolving as well, because the machines might change, the production process might change, the machines can extend. I mean, your own plant could become bigger. As such, you need ways to orchestrate these workloads that can be different across machines all around your factory. And I think that the piece of technology which I briefly went through, because I understand that in such a small time, it's very difficult to give you anything that is different than an eagle-eye view. These kind of frameworks are really instrumental to make this happen and to have the right technology that enables such use cases in the right way. But things get, let's say, a little bit more fun when you look at something that is completely different, just like the electric vehicles market. Now, in my own personal experience, over the last few months, I have seen a complete boom of the EV market when it comes to the infrastructure and everything that revolves around electric vehicles, because everybody is taking this whole EV thing as seriously as they should be. And the market is reacting by providing new products. But these new products are born with an opportunity. I think that the EV charger will become the next gas pump. But the gas pumps were designed way backwards in time, whereas the EV charging is becoming a thing as we speak. As much as we already have enough charger stations around, we don't have nearly close to enough to what are the targets that we have for transitioning to a more sustainable mobility. Now, this presents a huge opportunity for what concerns getting some action out of these charging stations. Now, you see some very, let's say, closed loop examples here of some things that we also designed internally for some of our customers. But the most interesting thing that you see is that sometimes these EV charging stations can run very complex workloads, as in a full HMI that could be, for example, an advertisement platform. Now, this gives you really a distributed fleet of smart devices, which are probably something more than smart. They can be a complete service provider. And these fleets are extremely, let's say, big in size. If you look at the average city with 8 million people in it, you can just do the math yourself and imagine how many EV charging stations you will need to get this city running 70% on electric cars, maybe. So we're talking about big numbers and a big fleet that you have to manage. And all of them can be used for, giving you, for example, an offer on the snack machine next door. They can be used for showing advertisements when they are not charging a machine, rather than do a lot of different things, and can also work in understanding what you want to do and understanding what is the way you charge your vehicle. They can tell you, hey, I can charge it slower or faster, but your usual habit is that you come to this EV charger and you go to sleep. So how about you spend a little bit less and you let me charge it a little bit slower because I have no other bookings. So the amount of things that you can do on these devices is, I probably don't even see through all of the use cases that such an example could have. What I know, though, is that exactly because of this is a typical use case where you need to stay relevant, where you need to have a product that evolves fast, and most of all, a product that adapts. The same pool of services that could work in a specific region, specific geography, specific language could simply not work in a different region. And so you need to act fast, and you need to have a system that on one hand manages a centralized fleet, but on the other hand has all the tools and the means to make it so that the specific of the geography, the category of the charging station, the whatever else that you want to tag and group your devices upon can be handled as a group and can be managed separately. And again, I think that if you look at this use case, it is pretty obvious why you need a specific technology stack that can embrace the full complexity of pulling together a distributed fleet just like that. Because at the end of the day, you have operations that are managing an ever-evolving product, a product that probably changes every 2 weeks or 3 weeks, because now you have the chance to do so. I mean, everybody likes stable products, who doesn't? But we are not talking about stability. We're talking about how the product works, and most of all, the fact that this product to the end users is no longer perceived as a product. It is perceived as a service, and it shall be treated as such. A service which remains static over time is something that has no value for the end customer or the end user at the very end of the day. And so this kind of, let's say, approach really enables you to build a next generation product. And when you look at the apps concept, as I mentioned before, this is also where you, as the owner of the technology, the owner of the product, can upsell and turn your product into a service by developing that tiny bit on top of all the rest of the framework that gives you that value add that you need to put upon your product to make it profitable. And of course, this is really the key for making these whole things work. I think the last thing I want to say before I wrap it up is that the real opportunity when you look at everything that I told you about, and starting from the concept of IoT as a mere data transport, from IoT plus AI, leveraging the edge computing and the cloud, becoming, let's say, a full value chain rather for your data. So it becomes really a way by which your data turn into value, is really what is getting this whole market and this whole IoT world attractive again. I believe that IoT has not been attractive for a while before we realized that IoT was not just about managing devices, doing software updates, sending a remote alert. All of this is cool and needed, but it was not as cool and as profitable as it should have been to make it very attractive. I think that now that we have all of this technology, now that we have all of these possibilities, now that users expect to have services rather than products, now that users expect a different quality when it comes to what they use in their daily, I think that now IoT is really becoming attractive again for everyone, for every stakeholder, from developers who now have exciting frameworks to try out and exciting new use cases to play with, to company stakeholders who now have new possibilities to look at their current products and business model and say, hey, you know what? There is an opportunity we might be missing here if we don't adapt, if we don't evolve. And so yeah, I think that ultimately it's a very good time to be in this market. It's a very good time to be a developer or a company in this market, because I think we are seeing a whole new spring for this. And I believe and I hope that, all the promises that we have been talking about for the IoT since several years now will eventually be fulfilled because of that. And again, embracing the full technology that we have and leveraging the edge, leveraging the cloud, and looking at the whole infrastructure as a whole really becomes the key to look at the bigger picture and put together something that really works and really is valuable. And Max, I think that is really pretty much all I wanted to say to our audience. So I take this back to you.
Well, thanks very much, Dario. That was very interesting. You made me think of all sorts of things there. And you're right that when the IoT first came along, I think we all appreciated the idea of the connectivity, edge devices, doing things and connecting to other devices. I don't think that many of us considered the amount of data that would be generated and how we would possibly use that data, because when the IoT first appeared, we didn't have AI, we didn't have the cloud. We had the internet. I remember when the cloud first came along and everyone was, what's the cloud? And now we just take it all for granted, but I think we still don't appreciate the value that's available in all that data. And having tools like yours that can extract look at the data and extract things that humans might not spot, because there's so much data there, and AI and machine learning can pull stuff out and go, have you noticed this causality? When this happens, and you go, wow, I didn't know that.
Yeah. So, and you know what, Max, about this, I would always like to say one thing that I probably have mentioned before. AI is really what you're talking about. To me, it's decision support. I mean, you always have to put things in perspective, right? So when you think about how AI really works, it's not a magic stick, as I mentioned. It's not like you see a talking face and somebody who tells you what's the future or what anything else. But AI can really help you when it comes to making decisions, because it can give you the insights and the points that a human cannot see, because data is machine readable by definition. And AI is meant to make something machine readable, human readable. So AI is valuable to stakeholders who need to make decisions. And it's really insights that can help you with that.
Right. I've got, you've given me a lot to think about here. So now it's time for our Q&A session. We've got some excellent questions and I'm very excited to hear your insights on them. The first one is, how would you define the current state of the art of digitization and artificial intelligence, and how big is this market, around the world?
So that's a tough question to answer. And I think that when you look at the state of things, you really need to separate verticals and look at what's the state of things in each and every one of them. IoT is, I believe, one of the verticals which bears the most potential for AI, but is still one of the less exploited when it comes to the potential that it can bear. And as you said before, Max, I do really believe that there is an ongoing mindset shift when it comes to the IoT and AI. So I think that almost everything that is considered IoT today can really be a part of the addressable market for AI, but we're still lagging a little bit behind. And there's probably a lot of work to do before we get to a massive adoption, although we are seeing some very interesting use cases, especially in the consumer space. Whereas I do believe that AI is making a big cut in other segments. And I could, for example, say that ERPs today are extremely ahead when it comes to artificial intelligence. If you look at big companies like Salesforce, SAP, they all make use of that to give, again, insights to whoever needs to make a decision. And I think that AI right now has been focused on the most strategic stakeholders, on C-levels, on sales executives, VPs, sorry. So by all of these, I would say that AI has been more focused towards helping the decisions of these kind of stakeholders in the company. Now, when we look at the IoT, we're looking at the AI giving some insights to whoever needs to be operating on the field or operating a fleet of devices, or even operating a specific, let's say, situation in which the field is meaningful. So I think that on that stage, we still have a lot of things to do.
Now, I was particularly interested when you said that your solution's targeted towards the front-end developers. Because so many solutions seem to be, focused on, the back end. But I'm a hardware design engineer myself, and so anything that helps me when I'm doing something at the front end, strikes me as being very useful. We have another question here. From a strategy perspective, what are the benefits for a company that decides to digitize its devices and truly analyze its data? So if we've got a company that's doing something, it's been doing it for a long time maybe, but they've not really thought about digitizing the devices and then using the data. So, from the strategy perspective, what are the benefits for that?
I believe that ultimately the lack of a concrete strategy is the main reason why adoption is not as fast as one can imagine. Because if everything that we said is true, and the IoT in general gives you a lot of data to use and to harness, but on the other hand, you need to know what to do with this data to harness it, because that's a pre-requirement. I mean, good things about the IoT, you can just collect random data and say, I will make some sense of it later. Bad thing about machine learning, AI, mathematics, everything else, before you get something out of it, you need to know what you're looking for, because you cannot just crunch some random data for an algorithm, right? So that is the bad thing about it, which means that strategically speaking, I will just say it again, decision support. I guess that when you look at a company today, you see a lot of things that are not being done because of lack of information. Everybody's talking about getting their products in the digital world, turning products into services. The answer is, if you want to do that, you need a consistent business model, You need a consistent way of making this work. You need data for making decisions even before you start using data for providing a service. So I believe that really the strategic benefit is that you can turn upside down the way you do business, and that you can have enough information that will help you making more sound decisions faster, and with data that is backing you up, which means if you go wrong, you can at least know why. And I think that's a good enough driver. But if you want to go to the more marketing pitch, I will say that if you want to switch to the business model of a service, you need that. So you will not just turn your products into a subscription because you're making them $99 a month rather than $99 on the shelf. You need to give users some value for making this happen. Users will be ready to pay a subscription. Users have never been more ready than today to pay a subscription, but you need to give them a reason why. And that reason why is a digital service.
I think that's very true, actually, because even myself as an individual user, if you'd asked me 10 years ago if I wanted to do regular subscriptions to many different services, I would have said no. And yet now, when I look at my credit card statements at the end of the month, I'm subscribing to a huge amount of services because they're valuable to me. I
Absolutely.
did
And I
notice
think
on
that
one
the
of your,
value is the keyword.
yeah, absolutely. Yeah, I wouldn't be paying for it if I didn't feel I was getting something back. You mentioned in the talk that you can save on the CPU costs in the cloud by pre-processing the raw data at the edge. But there are other advantages to processing at the edge as well. Low latency. So if you've got to make it, like you say, AI is making decisions, and there are some decisions that need to be made now, not later. And also, raw data is very noisy, and there's lots of extraneous stuff. And if you filter all of that out and just send useful information, you save on bandwidth, you save on costs and everything. So a question here actually relates to that. What is the added value that edge computing can provide to the AI algorithms? And what are the main advantages of a hybrid infrastructure where splitting the processing, I guess, between the edge and the cloud?
Yeah, I mean, I think you already gave a pretty good answer to that, to be fairly honest, Max. And all that you say is definitely something that I haven't highlighted, but are extremely relevant. And I will just make the obvious example. If you look at functional safety, you cannot wait for the cloud to do something. I mean, you need to take action in the right spot where a fall, where somebody getting close to a machinery or something else is happening. You can, as fast as you can be, you cannot bear the risk of an infrastructure which can be disrupted, by the way, just if the connection doesn't work as well as it should. So the reality is that the main benefit is the fact that you can do more. There's, as I mentioned before, and I would like to take again computer vision as the most adamant example. There are simply some things you cannot do unless you have an hybrid infrastructure. You cannot get, a people counting algorithm that is running on camera to be processing everything on the cloud. But you need the cloud to make it so that if you have, for example, a Bluetooth counting system like we had during COVID when we had contact tracing, and we have implemented one exactly with this kind of setup. You can have different gateways giving you the position of Bluetooth low energy tokens, but when you need to triangle all of them, you need an algorithm that is upwards. But you still need to find out what's happening at the edge before you go to that information. So I don't think there's there's a lot of key advantages, but there is one key takeaway, which is some stuff can be done only if you have an hybrid infrastructure. And I think that is the real value, because at some stage today you can do things that you could not have even thought about 5 years ago.
Well, and there's also the fact that if you just do something in a local environment like one factory, yes, you get a lot of information, but if you've got the same machinery in multiple factories scattered around the world, if something's happening in one of them and you can detect that and go, well, this is interesting, look at that, and then you see the same signals coming from another factory, you can use what you learned from, it scales up.
Absolutely. And there is also more than this. when you look at models evolve because of training. And of course, to train a model, you need the most data. So you can have a running model that is performing very well, but the data scientist behind you will also tell you that it can perform better if just they have more data, because that's what they do. So ultimately, the value of transferring data that matters, as you said before, because data reduction at the edge is such a big topic that we could just take another hour to discuss it. But taking the data that matters and getting it as food for training for these models is fundamental if you want to evolve and improve your performances. So yeah, ultimately we are always looking at something that is a sort of a constant retroaction that needs constant updating and constant data that should not be the big data that we've been fed with over the last I don't even remember how many years, but it has to be the right data, because big data today to people starts meaning it's too expensive. We need to send the right data. We need to ensure that the data we're looking at is meaningful even before we start processing it.
Right. So when you were talking, this one's a question from me. When you were talking, so the Clea is formed from three sort of separate pieces: the Astart, the Edgehog, which I love the name Edgehog, and the Clea portal. So we've got this software suite that allows the customers to gather the insightful data from their on-field devices in real time. Can you walk me through, or walk us through, the platform functionalities and the business model there?
Absolutely. So when you look at a starter, the main building block, that is what we call the data orchestration layer. Why is it data orchestration? Because ultimately, even if you're managing a device, if you're sending configuration or doing something, it's all data. So a starter defines a well-known framework for exchanging data between the device and something, which can be the cloud or can be an on-premise installation. Ultimately, as I mentioned before, anywhere a Kubernetes cluster can run, and it takes care of security, optimizing the data flow, getting structure, making it so that the devices are allowed to do just what they are supposed to do, and gives all the backbone that you need to build a product that is based on data and connected devices. That is, let's say, the main heart of the solution and the central hub by which we extend all the rest of the services. The SDKs at the bottom allow you to connect to a starter through an MQTT client, but abstract the detail and take care of all the certificate, the renewal process, the connection to the broker, the reconnection, the persistency of the data, the platform as a concept of eventual consistency, very useful for sending out configurations, for example. So it takes care of all this complexity and gives you just a very simple set of primitives that you can use for defining your data flow. And it's very extensible because you can literally define the data through atomic mechanisms and atomic definitions, which are called interfaces. On top of that, the Edgehog framework does everything that you can think of when it comes to device management. Device management to us means managing the life cycle of the device, not only knowing if the device is alive or not, but also knowing and updating the firmware if it's a microcontroller, or the operating system layer if it is a Linux-based machine, for example. Updating the application if they have a runtime for containers that support that. Update the configuration, or even getting access to a remote console in SSH fashion. All of this is built on top of the starter framework, so that you're not really using several different frameworks for doing the same thing. We have an application layer, and people also have developed their own services on top, because that is where backend developers, as you mentioned before, can chime in and do their own backends or extend the platform even. These two components are open source, and we also see a quite decent community adoption in non-commercial projects. You have administrator guides. If you look it up on GitHub, you can install both of them on Kubernetes and run them in your own cluster. And we're very happy if we know that your projects are running our frameworks. And the business model is just as any other business model in the market that is open source. We have a commercial portion of it that is either on these two frameworks, or most likely on the portal part that also contains all the apps and the front end developer framework, that we usually charge on a revenue share basis for the apps, and a cost that is metered as a subscription on the number of devices that you're currently running on the cluster. And when it comes to the business, we can either run your cluster for you, or we can act on your own cloud space or your own infrastructure and run the platform in a DevOps-like scenario to make it run and basically make it available 24/7 to your users with the uptime they expect. So the whole thing is very simple, very customer-oriented, because we want to make things simple for customers. We don't want to get them hidden costs that are that require a physics degree for making some sense out of it. So you have, the devices are your units of measure. That's what you look at. That's what you're paying for. And all the technology you're relying on, you can dive deep into the source code and even send us a pull request that we might reject, though.
Well, of course, yeah. Yeah, the main thing is it doesn't matter if the answer's no, so long as there's an answer. The last thing you want is to send off a request and never hear anything back.
We really care about the community. And just to tell you something, Max, SECO is a company that is comprised of a lot of people who have been grown up in the open source communities of Qt, KDE, Elixir, and a lot of other community projects. So we still contribute a lot back beyond our own projects and our own products. We hire consistently from the open source community, and we really act and work like an open source company. So it's one thing I really care about, because I'm coming from that area as well, and it's something I really care about personally, is that we are not the fake open source company that just throws some source code on GitHub and pretends that it's an open product. No. We are developing open frameworks, and we care about it, and we know how to do it.
And when you think about the hundreds of thousands of person hours involved in creating all those open source portions, you just couldn't do that by yourself. But people can take Clea, like you say, the open source part, and then add their own secret sauce on top, differentiate themselves.
Yep.
So it becomes very powerful.
That is the point. That is the point, and I do believe that, power to developers, right? Today, the main point is companies, but even users. I mean, if me and you wanted to start a small connectivity product, we could just take some source code from the internet. We are skilled enough to make it run. We can build our own mobile application, and there we go. You connected your house to the internet. But of course, that's the developer scenario. But companies today can rely on a lot of pieces of technology, and Clea is just one example, and IoT actually is even just one of the examples, and can add their own secret sauce, as you mentioned. And that is, the secret sauce is the added value. And today, developers within the companies or system integrators can really bring to life all of these services with extreme ease and a very, very low total cost of ownership. Because, as you mentioned, there's, I don't even know how many years within those products. There's hundreds of thousands of lines of code and a lot of experience. Most of all, it's just about the code. It's about, we've seen what happens on the field when you do the wrong thing, and we encoded that experience in the way these frameworks work. So it's such a big opportunity today to develop on top of these things.
We've got two related questions here, so I'll ask them as one. How does Clea enable? How does it really enable the edge to the AI integration? And how do Clea apps work?
So these two questions are very closely connected, as you mentioned, because the two concepts are very similar. So the edge to AI, the edge to cloud integration, and the edge AI integration is enabled by the fact that we allow to bring down and configure data pipelines at the edge. How do they work? You can write down your own pipeline using either a visual editor or building your own container, because we also allow you to encapsulate your ML models or algorithms within a container, and let just Clea orchestrate that on your chosen portion of devices or your chosen geography or your group, as I mentioned before. So you can logically split your fleet and define deployment policies that then go cascading on all of your devices that you have selected. And these really enables you to do updates, which are not just software updates, but are configuration updates, application updates. They update how the data pipeline works and how this ends up at the end of the chain. The way the applications work is that you have, let's say, a way for developing your own front end in a container using your favorite JavaScript technology. So at the end of the day, you can build a container that has a front end part and even a back end part of it if you want, and you can connect this container to an edge container. So In some ways, you can have what we call convergent applications, which is a very new concept that we are still developing, by the way. And these allow you to have one single app that you can deploy on the platform and let the platform orchestrate that in the way in which if your user enables the app on the device in the cloud automatically deploys the portion at the edge on the edge. This makes sense because one of the next updates we will release very soon is the concept of a private app store within Clea, in which you can have your own billing mechanism, in which if you want to sell value added, if you want to sell your own secret sauce, or we'll use your own words, you can also integrate it with a billing concept that will deploy the right portions on the device, just if your end user is paying for it and is paying the subscription you're looking for. So we are trying to make sense of the vision I gave you before by giving you all the tools to make it happen.
So in the future, people will be able to get Clea apps, and almost like I'm thinking of some of the graphical tools that we can use for hardware design, where you just drag a processor and drag a bus and then drag peripherals and put them on. I can imagine a future where you go to a Clea store with Clea apps and you pull one down and the output of one app feeds the next app and the output of that app feeds the next app, and you build a super app. Maybe you put some, again, a little bit of secret sauce, but you take advantage of everything that's out there to create something completely new.
Absolutely. But I think that this is, I think, the far future. What I see as the near future is the fact that, let's say that me and you have built a connected product, and we have built 10 apps for it, and we decide to build them differently because some of them will be free, some of them will not be free. Now, through the platform, the end user will do this drag and drop that you mentioned, and will build its own digital service, starting from what the product can do based on what he wants to spend. Think about it as a premium subscription to Spotify, in which you get no advertisement, but you get the full track and you get to choose the track. Now, it is not the right example when it comes to the use case, but it is the right example when it comes to the user can decide what and how to pay for it. And they can drag and drop at that stage for real their own services. Then yes, I mean, I believe that the technology we're building can enable a scenario just like the one you mentioned. And I think that if you look at what people are doing in the zero code space, it is a future that might happen. But personally, I think that I see a lot more potential in allowing the people to build their own digital services in a modular way and let their users choose what they want to pay for.
Right. We're running out of time here, so we've got time for just one more question. And we really are running out of time if we want to keep to the hour, so please answer it quickly. While I ask this question, Dario has told me that you can feel free to contact him directly using the contact details shown on the screen. So, last question, what's next? How do we all generate even more value across each vertical?
Try it out. Because the only way you can generate more data on each vertical is to try putting things in production and ensure that you listen to your users, you look at your data, and you make sense out of your data. Because ultimately, the value is already there. You still haven't harnessed it. You still haven't told to your users. You still don't know why your users want to buy your product sometimes. So you need to play around with it. I think that, again, that shows the value of having a framework that can evolve over time, because what your users want today might not be the same thing you will serve them tomorrow or what they will request 1 year from now. So the way forward is always upwards. Let's get more data out in the field. Let's do it.
Okay. Well, thank you so much, Dario. That was very, very interesting. This brings today's webinar to a close. I'd like to thank everyone for viewing, and to give a special thanks once again to SECO for their sponsorship, and especially to Dario for his insightful presentation.
Thank you very much, Max.
Oh, it was my very great pleasure. All of the questions you submitted will be forwarded to Dario, so he will respond via email to any questions that we didn't have time to cover today. Once again, this is Clive Maxfield, and I'm very pleased to have been your host for today's event. I look forward to seeing you all again on the next IoT Central webinar. And until then, from all of us here at IoT Central and SECO, we hope you have a wonderful rest of your day.
Thank you very much and have a great day.